Alrighty, well, welcome everyone. I'd like to say good morning and thank everyone for taking the time to join the webinar today. My name is Jeff Baker and I'm going to be presenting with Jeff Wheeler today about why heaters fail. So without further ado, let's get started. So who is Nexthermal? For those that don't know, we've been in business since 1986. We actually began manufacturing in Battle Creek in 1991. We also have a large factory in Bangalore, India, and we are a minority-owned company that is ISO certified in both locations for manufacturing. We have a mission and vision statement. I'm not going to go over that today, but I just want to share that we have a very sincere focus on charitable giving and contributing to different organizations, both in the Battle Creek area and in different things across the globe. It is very important to us as we continue to grow and get larger that we do our part to do things in the environment and with society to help others as well. So that's a key part of our mission. We first and foremost pride ourselves in being a thermal solutions provider. So what does that mean? You could call us and simply place an order for 10 or 20 stock heaters or standard heaters that could be easily configured online with our online configurator. Or you could call us and we could help you design a complete heating system that would include heaters, temperature sensors, possibly a PLC controller, and then we would build that whole system in-house, test it, and then ship it to your facility and help you integrate it with your current system in your factory. So pretty broad, pretty expansive capabilities. But what we really focus on is energy savings, increased production throughput, improved quality of your end product, and then decreased downtime. These are some of the products, mainstays that we offer: controllers and heating systems, as I just mentioned. In the middle there, you see a picture of our new single loop controller that's in a NEMA box with a safety interlock on it. And that's a fully integrated control system in an enclosure that we sell as a system. We do heater assemblies, like in the top left there, a top sealer. That's something that we've designed specifically for one specific customer to help them run faster. We do thermal simulations and through FEA, and then we do custom heating solutions quite regularly. Work with our engineering department and help customers develop a new concept or a new idea that they may have, or something that they've been doing but they want to improve efficiency. We also manufacture cartridge heaters, coil heaters, tubular and immersion heaters. We manufacture temperature sensors, and as I just mentioned, custom designed heating solutions. So, why do heaters fail? What we're going to narrow it down to is 4 main things, because 95% of all heater failures usually are attributed to one of these 4 things: fit, movement, moisture, and contamination. So the first thing we'll talk about is fit. And here's an interesting story that I'll share with you real quick. So we had a customer that had 2 different heater companies come in and supply heaters to them. And with both of those heaters from 2 different companies, they failed within a couple days. So both companies had asked, what the diameter was that the customer required, and then they supplied a heater based on what they were told by the customer. So when Nexthermal came in and visited the plant, we heard the story and knew something was a little bit strange. So we looked at one of the heaters, and when, like in the picture you see there, it looks like, oops, excuse me, let's go back. In the picture you see there, you see some discoloration. So we looked at that and we said there's something strange going on here. So we took a pair of calipers and measured the bore and found out that they had an odd sized bore that didn't match up with the diameter that they were providing. So we solved the customer's problem simply by measuring the bore, which, you know, is something that most people would think would be common sense, but it was something that when you see the discoloration there, you know something's wrong. So with fit, and we see a lot of heater failures because of fit. It can be caused because of a damaged bore from drilling heaters out previously. It can be caused by poor tolerancing, or it can be, in the case that I just shared with you, an incorrectly specified heater diameter. But why is that important? Well, when you look at poor tolerancing and you see, say, for example, 1/1000th of an inch of extra clearance, that can increase the core temperature of the heater by up to 200 degrees, which then increase the sheath temperature, and over the long run does cause the heater to fail earlier. So there's a picture, the outside showing the discoloration. The inside there, you can see the breakdown of the ceramic because of extreme heat. So there's a British Stainless Steel Association that actually published quite a long time ago this color chart that shows what temperatures were reached at certain colors when it's displayed on the sheath. And in the previous example, you saw the dark blue color there, so we know that that heater saw at least 1100 degrees F, and possibly even a little higher. When we talk about the effects of air gaps that would come about because of a poor tolerance, here's an example of a heater running at 600 degrees F at the case, and we're assuming a couple things here, but at 129 watts per square inch and a perfect press fit, the core temperature of that heater is probably going to be somewhere around 760 degrees F. So that's in a perfect world, perfect scenario. When you add that 1/1000th of air gap there, what you see is an increase of core temperature by an additional 200 degrees, and then increasing the sheath temperature as high as 961 degrees F. So, and with thermal delays, you would see that temperature even go possibly higher. So that's one of the reasons why we stress the importance of good tolerancing and good fit of the heater. Another thing that's associated with fit quite often is set screws. If the heater's too loose in the bore, sometimes we'll see customers that use set screws to hold the heater in place. If the heater's toleranced properly and set screws used in the right location, it's okay. But if a set screw is used where the nichrome wire is in a heated section of the heater, and if it's over tightened, bad things usually happen to the heater, and quite often you see premature failures, and you'll actually see a little mark in the heater where the set screw is tightened down. Also, if a set screw is used on an improper sized heater, that set screw just pushes the heater against the opposite wall of the bore, causing an uneven heat issue, and uneven heat on the heater also causes premature failure. Okay, so moving on to movement. This is another common failure mode that you see a lot, especially when there's high movement or excessive movement or vibration. With excessive vibration, we also can see internal damage to the ceramic core. But with movement, generally, it's usually revolves around the leads fraying or breaking. Problems with, so when you route heaters with high movement, you might have a pinch point or a rub point where something eventually rubs and the wires short out against a piece of metal or against each other. There's also issues with flexing, and if routing isn't done properly for the wires on high movement, those heaters flex to the point where either where the leads exit or near the exit is usually what happens is the leads eventually break off. All right, moving on to moisture. Let's talk, as you can imagine, moisture and heaters don't usually go well together. And moisture can be in multiple forms. So in like a food processing plant where you would see a regular wash down cycle every day, that's an obvious point where everybody's aware that it's high moisture, and we design a heater to withstand the sterilization process with either hot water or steam. What's far less obvious is moisture that's not visibly present, but you know it's there because you feel it in a high humidity environment. And that can be high humidity in a factory or a plant, or it could be, humidity in a storeroom or in a stock room where heaters are being stored on a shelf for a long period of time and it's not temperature controlled. So heaters with ceramic potting are essentially will breathe. When the heater's powered up, with humidity and high moisture environments, you have this potential for moisture ingress as the heaters essentially breathe. This breathing is caused as the heater cycles between getting hotter, and then the heater is energized, and then it cools and power is removed. So in that effect, as it goes on and on and on, it's actually causing the heater to breathe. And if the heater is powered up too quickly, part of that moisture will be driven out of the heater, but part of it's also going to be driven in internally towards the tip of the heater. So as this happens repetitively, moisture accumulates until there's a path of least resistance, and as you can imagine, bad things happen between the resistance wire and the sheath. Contamination is the fourth failure mode that we'll look at. This is probably the least common of the four failure modes that we'll talk about today. It comes in different forms, and it can affect both external parts of the heater and internal components. With contamination, some of the common sources come from extreme environments such as zinc die casting or caustic gases that may be absorbed into the heater much the same way that moisture is absorbed. We've also seen contamination react negatively with common lead materials like fiberglass, silicone, and Teflon. And that contamination can actually degrade that material to the point of failure. And if it's not a failure, it also might create a safety concern with bare wires being exposed over a period of time. So common sources, of course, processed materials, leaking oil, and then lastly, probably quite regularly, we see installation compounds that have been applied to a heater, and those weep into the potting at some point and then affect the internal construction of the heater. So that's the bad parts. Let's talk about some good things now, things that Nexthermal can offer to help combat some of those four failure modes that we just talked about. So when it comes to fit, one of the unique options that we offer is called centerless grind. And centerless grind tolerance for cartridge heaters specifically. So when you talk about centerless grind, we have to look at what the industry standard is for tolerancing on this type of heater, on a cartridge heater. That tolerance usually is running somewhere around 0.004 of an inch. At least that's what most heater companies publish for their cartridge heaters. We have taken some of our competitors' heaters and measured them and found that that's even a larger tolerance than what's published, but 0.004 is kind of the norm. A centerless grind tolerance, which Nexthermal offers, brings that tolerance down to right around 0.002 of an inch. And holding that tolerance requires extra machining and manufacturing time, but the end result is it puts that heater into a properly sized, if you put that heater into a properly sized bore, the heater will be more thermally efficient and will have longer life. So that translates to less heater changes, less downtime. But we also have the ability to customize the diameter of the heater. So if you have an irregular like sized bore, like the example I mentioned earlier, we can design a custom tolerance to fit that bore when you have an odd size bore. Another unique feature that Nexthermal offers as an option is what we call our anti-seize coating. This is a coating we provide that can improve thermal efficiency and also helps ease the removal of the heater from the bore. So unlike coatings that are applied in the field, which actually add to the diameter and are typically pushed off of the heater as the heater is inserted into the bore, when the coating option is ordered from Nexthermal, what we do is we actually undersize the diameter to account for the thickness of the coating. So the final OD of the heater with the coating falls within the same tolerance as a heater that would be ordered without the coating. So when you put the heater in the bore, the coating's not coming off and you're actually getting the full effect of it. In regards to movement, we have a couple of options there as well. The T-strain that you see in the picture there at the bottom, that's kind of a support mechanism that we actually attach to the heater, and it just helps support the leads at that spot where the leads exit the heater. In high movement applications where the leads are not properly routed, quite often that's the break point or the point where we see heaters the leads start to wear and eventually break. We also offer right angle exits that help with routing and make sure that the leads aren't bent a certain way as they're coming out. There's flanges that help mount the heater so it's not moving around. I actually went to one customer once where they didn't have a flange and the heaters were coming out of the bore during the process of a platen moving up and down. And eventually they'd come out and the leads that came straight out actually hit the machine and shorted out and broke. So flanges can help, keep heaters in place. And then in really extreme cases, like you start talking about packaging jobs where you're running 60 cycles, 70 cycles a minute, quite often we'll use a high strand lead wire to help with the flexibility of that wire, and that does help increase the life of the leads with that higher strand count. With moisture, you've got a couple options there as well. Silicone and epoxy potting are quite often used. With our coil heaters, it's our standard to use a moisture resistant epoxy, and we actually water bath test the heaters 100% before we ship them out. We also have moisture resistant lead wires. Teflon and silicone both work well. And we have a armor cable with heat shrink that also works really well. And then important too, we talk about soft startup. So when I mentioned earlier about moisture getting inside the heater, one thing you can do is use a soft startup cycle, sometimes built into the controller, where it ramps up the voltage input to the heater when you first start it up. And that slow application of power to the heater helps just helps work the moisture out rather than shock the heater with full power upon startup. And if you do that, and there is a little bit of moisture, say from humidity in the heater, it helps remove that moisture without damaging the heater. Contamination, again, similar to moisture, you have to be a little bit careful as to what you're using, especially in regards to Teflon or silicone. If there's caustics or chemicals in the environment, you have to make sure that the materials being used are appropriate. But we still use silicone and epoxy potting quite often. We also have a gas-proof armor cable. That's what you see there, which works really well at keeping moisture out and keeping corrosives from entering the heater. So that's something we can offer as well to help with contamination. So I haven't talked about all of the things that Nexthermal can offer to help some of these failure modes. We do have a lot more options and don't have enough time to cover them all. So I'm just sharing with you, if you've got a unique application or something where you feel the heater's not lasting as long as it should be, then give us a call. Talk to one of our engineers or one of our account reps are very knowledgeable in looking at applications. We'll come out to your plant, come out and visit you if you would like, take a look at what you've got and make recommendations on how you can improve heater life, or possibly how you can improve production speed, downtime, things like that. So I think that's the majority of everything I wanted to cover. So I'm going to now hand this over to Mr. Jeff Wheeler, who's going to hopefully got some questions coming in on the chat line, and we'll be able to address those questions and answer them for you. So Jeff, I'll hand it on over to you.
Thank you, Jeff. And as Jeff said, this is Jeff. So I do have some, it causes a lot of confusion here in the office too, so don't feel too confused. We have a number of customer questions that have come in during this conversation. So I'll try to pick through some of these. Probably the first one I want to bring attention to is, Jeff, you showed a slide of fiberglass wire that was braided, that had broken the outer sheath due to movement. I should also point out in that slide that we do use Teflon quite a bit in like packaging applications. That's a very high movement. Machines could be cycling up to 200 packages per minute. Our Teflon is a good choice for those applications. They are susceptible to cold flow. So Teflon will split open if it's pinched or under clamp pressure or a sharp bend. Over time, it will actually separate from itself and cause a situation just like you showed with the fiberglass wire where it will expose the conductor. So Teflon's not inert to that problem. We just have to make sure we follow good routing guidance and don't pinch it. There are different grades of wire out there. There's PFA and Teflon, which is PTFE. We principally use PTFE because it's a little bit more resistant to that problem. There are people out there that use PFA, and the cost can vary between the two options. But we prefer PTFE as a sintered product, so it's not wrapped and extruded, so it doesn't have the opportunity to really split open like a PFA would. So I did want to point out a question that, and I have a question here. How do you combat moisture problems with heaters stored in humid environment? There's a lot of different answers to this question. So first of all, if you have a ceramic heater or a heater that's exposed to a high humidity environment and you're concerned that it may have absorbed moisture over sitting, there is a soft start procedure that most modern PID controllers will implement when you first apply power that applies 50% duty cycle until the heater is dried out. And then after it reaches above boiling temperature, it goes to full power, assuming that all the moisture has been driven out of the MGO. We do package our heaters in a pink poly bag. That's a coated poly bag. So as long as the poly bag has not been opened, the heater will remain dry. But we still always recommend the soft start process. There's also, as Jeff alluded to during the PowerPoint, there are different potting options that we can use to try to protect the heater. High humidity environments do have a way of working their way into the heater eventually. So regardless of the potting, you always have wire strands that come through the potting, and there's a point of entry through that. So over time, you will still have an entry point. Let's see here, moving on. So there's a question here, what's the purpose of the stepped or knockout tip on the end of the heater? It allows easier removal because you definitely don't want to take a hammer and punch on the end cap of the heater. It'll just swage out the heater into the hole and lock the two together. So adding that little tip on the end allows the force of the hammer and the punch to transition to the sheath of the heater and more promote a sliding effort than a swage into the hole effort. Okay, let's pick through this list here. Anything over there, all right. Okay, this is a pretty common question we get. How sealed is the heater? So when we talk about sealing, we use the term IP rating. Protection is an IP rating. 67 is what we normally advertise as the product is capable of reaching. It could actually, in some cases, be designed to reach above that. But I think if due course with our standard materials and processes is used, we could hold a IP67. I don't really have a PSI that's just IP67 as a specific condition of how much water over how many minutes. All right, what other questions we have here? So, well, that's a good question. Why would a heater trip GFCI outlet? So, a ground fault interrupter works by measuring the amount of current going down a hot line and coming back on a neutral line and comparing the two. So it knows it sends X down one line, it should see a derivative of X coming back on the other line. And if it doesn't, then it assumes there's a problem and opens the connection. The issue with the heater is it's very much a capacitive device. So the magnesium oxide acts as a capacitor when the heater is first energized. So there is a brief moment in time when you first apply power that there will be an imbalance between the hot and the neutral lines. There's also induced voltage to ground, but that doesn't really get picked up by the GFCI. It mainly sees that imbalance and immediately turns off the power. There are industrial grade GFCIs that have adjustable limits up to 15 milliamps. Those are better than one that you buy at Home Depot and put in your wall. And there's also circuit interrupters that are a better choice than a ground fault interrupter if you're concerned about safety. So there is a tech brief that is written on that, and we can share that to people that have more questions about what device is better for protecting operators using equipment with heaters installed in them. A question here about recommending anti-seize lubricant on cartridge heaters. So yeah, there is a number of different products in the market. Obviously, Jeff talked about the coating that we offer on our heaters. We have two different versions now. One, which he had the picture of, is a very good solution. Does have some material compatibility issues if you have cleaning agents in your process or high humidity in your process, like packaging machine for aseptic washdowns or something along those lines. You probably wouldn't want to pick that coating. We have another version that we've introduced that performs better than the coating in that picture for those applications. That being said, there are other products on the market. You have to be careful. There is some competitors' products offering that has carbon or graphite embedded into the product, and it's basically a lubricant that you put on the outside the heater and you push it in the hole. The challenge with that product is when you push in the hole, it tends to spooge out over where the lead wires exit the heater, and because there's graphite in there, and it's an oil-based product, as the heat goes up, the lubricant gets wetter, it gets sucked into the heater, bringing that graphite in with it, and it can short out the heater. So we don't prefer to use that. We don't suggest customers use that. For high temperature applications, I found there's a Loctite material called C5A, which works very good. It's a copper-based, has the same contamination issues that the other stuff does, but usually with higher temperatures, you can take more care to make sure that it's cleaned off well. Question is, have we had good feedback on the anti-seize coating? Yeah, the customers that have used it, it has definitely solved their problem. You know, the whole purpose behind having anti-seize coating is to promote heat transfer off the heater. A lot of times I refer to a heater as like a light bulb. So you have a standard incandescent light bulb and you have a halogen light bulb. Halogen light bulb needs the heat to be dissipated off. That's why you can't touch the bulb casing. It'll increase the temperature inside and cause it to burn out. Very similar to a cartridge heater. If you have an insulation around it, like air, as Jeff pointed out, it will increase the core temperature and cause it to prematurely fail. So the anti-seize coating helps not only with preventing the heater from being non-removable after failure, but it also helps with heat transfer. So you want to find something with good thermal conductivity as well as high temperature rating. So there's a question here about split tube heaters. They're pretty common in the marketplace. We do face this question quite a bit. You know, the issue with a split tube heater, from our perspective, when they're manufactured with a spiral, which is stretched by hand. You're not able to control the watt density very uniformly over the length of that heater by the manufacturing process that those are made with. Our heaters are wound onto a hardened core. They're computer wound by a CNC machine. So the winding pattern, the equivalent to the watt density of the heater, is uniform over the entire length of and it's controllable from heater to heater to heater. So you're always going to get the same. So when you look at like median wattage distribution, for instance, to compensate for a packaging jaw temperature profile issue, the computer wound heater is going to be much more precise and much more reliable from heater to heater than the split tube heater. So we control the fit, we control it with the coating. You know, we try to get the heat off the heater into the tool efficiently, quickly, so the system is controlled better through the controller. The split heater, because you don't have a lot of heat contact other than the 2 points when the heater opens up, it can be a little sloppy. So I think we have a good answer for split heaters. So the new anti-seize coating, there's a question about that. The temperature rating is similar to the ceramic. It works as it's rated up to 750 degrees Fahrenheit as a lubricating agent, and above that all the way up to 2400 degrees as an anti-seize agent. So obviously it delaminates from the stainless steel sheath above 750F. I suspect a lot of our customers are not driving them that high. So there's a question here about the anti-seize coating, whether it's hardened or not. It does come already coated onto the heater. It is a hard coat application. It is conformal, so that when it gets pushed in the bore, any extra that may be preventing heater assembly to the hole will shave off during the assembly process. So it's hard enough to absorb the rigors of transport and packaging and distribution, but it's soft enough where it can conform to the hole as it's being assembled. So looks like we've gone through a lot of the questions. Jeff, have you seen any that I've missed in this list?
No, I think
it's a little difficult to just talk to myself here, you know.
Yeah. No, I think that, you know, you did a good job covering all of them. We'll go ahead because we've already gone over a little bit. I don't want to get into people's lunchtime, but I did want to just close out and say thank everybody for, you know, coming in and joining in on the fun today. Hopefully everybody learned something and got something out of it. We've been
We're
doing
always available if there's more questions. They can always shoot us an email. They have our contact, right?
Right. That's the most important thing is we really, you know, want to work with customers and as I said earlier, you know, you can call us, we can configure a heater in 5 minutes online, or you can configure a heater with our online configurator, and we can build a heater in you know, less than 2 weeks, a custom heater that you design online, or we can, you know, have a discovery meeting. We can sit down with you. We can look at what problem you're facing or what issues you'd like to improve on, and we really enjoy doing that part of it. That's, if you look at our website, you see a big focus on solution orientation. So we don't want to be a Me Too heater company. We want to come in and help you solve a problem or help you improve something, and that's what our whole staff is kind of focused around. From, you know, from engineering, even our salespeople are very well educated, they're very well trained. Most of them have been on staff with us 10 years or more, so they're very knowledgeable, and if they don't have an answer for you right away, they get an answer very quick by calling Jeff Wheeler.
Or Jeff Baker. There was a question that I missed that I did intend to address. There was a question about if we use Duraflex lead wires, and why I won't necessarily get into the specifics. Our lead wires are custom made to our specifications, and I think a conversation, whoever asked that question, the conversation with your salesperson could go over the advantages very quickly. We're familiar with Duraflex. There are some heaters that customers ask us to specifically use that wire. That is not our standard wire because we find some disadvantages with using that product that our standard product addresses better. But there are some sticklers in the mud out there that want special wires, and unfortunately we do that. But I did want to point that out, Jeff. Sorry.
Good. No, that's a good point. You know, there was, one of the high movement application customers we had, we had wires, and we tried a number of wires, and then they gave us a wire that they wanted to try, and we ended up sourcing that wire for them and using that wire exclusively for one of their heaters that nothing else would hold up for. So I buy a lot of that heater, and we spent many hours doing time studies with them trying to figure out which wire would hold up the longest. And they had wires that on the specific movement application on a packaging machine that the wires were only lasting 5 to 7 days, and now they're lasting 4 or 5 months, and they're ecstatic. No. So we worked with them. We did a time study. It was a 10 or 12 page report that got created, and in the end, we sourced a new wire for them, and they're very, very happy now because their downtime's been significantly reduced. So we like doing things like that, and so give us a call, and we're happy to work with you. So thanks again, everyone, for joining the webinar. We will be putting this on our website, so if you want to go back and listen to it later, it will be available probably later today or tomorrow. And we'll be doing more webinars like this in the near future. So hope everybody has a good rest of your week, and we'll talk to you soon. Bye-bye.
Bye-bye.